Continuing on with our quadratics review, and we are looking at standard form equations throughout this entire page here, and working through situations where we either have something already cleaned up and we're ready to identify key features and graph it, or just get the x-intercepts, the solutions, through the quadratic equation in something that may or may not even be graphable easily. So we are going to start out with this one. Whenever we have this problem, I like to start out with the x-intercepts, and that is based on factoring. So the x-intercepts comes from factoring the equation. And so to get that, I take this base equation right here, and I want to get a positive 1x squared so I can do factor it the way I would generally factor a trinomial. To do that, I see that I have a negative in front of that x squared, which is really a negative 1. I'm going to factor out a negative 1 out front, leaving me with positive x squared. Dividing out a negative 1 gives me positive 4x, and then dividing out a negative 1 from the 5 would be a negative 5. And so I have that as my more factored form. In order to factor that trinomial there, I need two numbers that multiply to negative 5 and add to positive 4. 1 times negative 5 would do that. If I add those up, I see that I add to negative 4. Well, I want positive 4, so a quick fix to that is to just invert my signs. So I now have negative 1 and positive 5. That adds to positive 4, still multiplies to negative 5. So my factored form is going to use those two numbers, the negative 1 with x minus 1 and the positive 5 with x plus 5. The last step of using that part to get the x-intercepts, because I started at the bottom with that, is to say what makes each of these factors go to 0. Well, I know that a positive 1 is going to cause that at 1 minus 1 is 0. A negative 5 is going to cause that one. So now I have my two x-intercepts I can write in below. So 1 and negative 5. And if I'm going to my graph, I can immediately on the x-axis put a positive 1 and a negative 5 right there on the graph. So there they are. The rest of these is going to use some other information. I'm actually going to do my vertex line of symmetry min-max last. So my width coefficient and my y-intercept comes straight from the problem. A is always the very first part, always the number in front of x squared. And even though it's just a negative sign, we know that that really means a negative 1. So A is negative 1. I can just write that in. My y-intercept is what happens when I plug in 0 for x. And when you plug in 0 for x, this term goes to 0, this term goes to 0, and you're always, in every situation, going to be left with just that last term, the c value, which in this case is positive 5. So our y-intercept is going to be 5. And I can also graph that right away. So right up here at positive 5, I have a dot on the graph. Last thing is I want to do the vertex, and you get that by getting your line of symmetry, plugging that in, getting your min and max. I'm going to clear out some of this so I have some room. You might need a separate sheet of paper. In order to get the line of symmetry, the x value of my vertex, I need to do the negative b over 2a, x equals negative b over 2a equation. So if we write that out, x equals negative b over 2a. We want to utilize the a, b, and c that are up here, these values. So a is negative 1. We already wrote that down. B is negative 4 next to the x, and c is positive 5. You can only do that because those terms are in order. That'll matter a lot in any situation where you use those letters. So negative 4 over 2 times negative 1. Negative 4 is positive 4. 2 times negative 1 is negative 2. And 4 divided by negative 2, negative 2. That means our line of symmetry is x equals negative 2. And so if I were to graph that, I could do a dashed line at x equals -2, just to help me see my symmetry. But I'm going to be plugging that -2 back in to the original problem in order to solve for the min-max, the y value. Now, one thing I noticed right away is my two x-intercepts actually mirror very nicely on either side of this dashed line. If they didn't, something would be wrong, because it means that I wouldn't have an accurate reflection back and forth like that. So once again, I'm going to clear out a little extra space here, and I'm going to take that -2 that I just got. I am going to plug it into the original problem. So I have -2 squared. Notice the extra negative in front of the x squared. I also have to write that. I could write it as a -1 out front if I want. And in fact, that will probably keep things cleaner if I do that. So -1 times -2 squared minus 4 times -2 plus 5. Order operation says I need to square first. So -2 times itself. Negative times a negative is positive. 2 times 2 is 4. So I have 4 out of this part right here. So I have -1 still out front times the 4 times the positive 4. Now -1 times 4 is -4. This is the part where people make the most mistakes, because what people want to often do is say -2 times -1 is 2 and then square that after. But in fact, you always square first. That is a higher operation on the order of operations. And then the multiplication of the -1 or the negative sign, quote unquote, would come last. -4 times -2 is +8, and then plus 5. We add those two. 8 and 5 is 13. Take away 4 is 9. So our min or max is 9, our height. So if I look at my dashed line, I'm going to follow that up to a height of 9. And that's where the vertex is going to be. So the vertex is at the point -2 from the x and then 9 from my min-max. Based on the graph that is shaping up here, and the fact that my a value is -1, meaning that if I go from that vertex over 1, I'm going to have to go down 1. I'm looking at this a value here, and that's going to inform the point 1 over on either direction from my vertex. I have to go down 1. It's becoming pretty clear that this graph opens down. The negative says it opens down, meaning that that 9 is the highest point on my graph. It is a maximum. It will either be the highest or the lowest. So I've got my vertex at -2, 9. I added 2 additional points here based on that a value. And at this point, I have all this information filled in, and knowing that it's symmetrical, I can draw a pretty decent approximation of this graph. So I will do so. So I will come up through here, swoop down, and then it should look something like that. So although not perfect, I was able to hit a number of key points that I had figured out here and make a pretty decent drawing of my graph. Last example down here is what happens when we have a quadratic equation that can't be quite so easily graphed. And so the way I like to work these problems is I always go to the left. I struggle with getting everything on the right side of the equation, even though in this situation it might be easier. I'm going to get everything onto the left side and then make sure it's in x squared x number order in standard form before I do anything, and then I'm going to use the quadratic formula to help me solve. So since I have things on the right side of the equal sign, I'm going to subtract 4x squared from both sides. I'm going to subtract x from both sides, and I'm going to subtract 1 from both sides because I have a positive 1. So 1 minus 1 is 0, x minus x is 0, 4x squared minus 4x squared is 0. The right side of the equation I got to 0. Now again, you could choose to move everything to the right and keep the left 0, personal preference. I have positive 1x squared minus 4x squared. Don't forget that that's a 1x squared. So 1x squared minus 4x squared is negative 3x squared. I then have, so I'm going to cross those out, stay organized here so I don't make a mess. I have minus x, or minus 1x. I'm going to write out the 1 that's not shown. And then I have positive 3 minus 1, so that's really positive 2. And that's all on the left side. All of that is equal to 0. Note that I also made sure I wrote it with the x squared term first, the x term second, and the term without any x's, the constant, last. That means that I am in A, B, C order. If I rewrote those in the wrong order, I would not have A, B, and C, and I would get some very different answers. From there, now I am ready for the quadratic equation. That is a formula that helps me solve for x-intercepts, also known as the roots, also known as the solutions. Poof, like magic, there's the quadratic equation just when you need it. We are going to use this messy formula, plug those A, B, and C values in, and use that to figure out the solutions, which may or may not be real numbers, may be imaginary numbers, meaning that there's not an actual x-intercept because it doesn't cross, but we can still use those values in other ways. So let's plug this in. Negative b. b is negative 1, so that's going to be a negative 1 plus or minus, how we read that, square root of b squared, so negative 1 squared minus 4 times a, which is negative 3, times c, which is positive 2. I like to put parentheses around anything with negatives so I know that I'm multiplying, not adding or subtracting. All of this is over 2 times a. Make sure your fraction bar extends all the way back to the left. A lot of times some people forget to do that. So let's work out the math in each of these parts. Negative 1 is positive 1. So that first part is positive 1 plus or minus square root of, and we're going to clean this up. And I like to write this as a little sidebar up here. I've got negative 1 squared. That means negative 1 times negative 1. Negative times negative is positive. 1 times 1 is 1. And then I have minus 4 times negative 3, which is positive 12, times 2 is 24. So I have plus 24. So that's going to be 25 inside the root. And all of that is over 2 times negative 3, which is negative 6. So I've got that boiled down quite a bit. At this point, I do not need to think about imaginary numbers because I do not have a negative value inside of that square root. If I did, let's say if the problem was negative square root of, or square root of negative 25, I would have to rewrite that as I, imaginary number, root 25, so that I could actually take that root. Now in this case, not an issue, so I don't need to worry about that, but that's something that could absolutely come up. Continue forward. The square root of 25 is a known number, so instead of using either a reduced root or a decimal approximation, I can take the square root of 25 and it's the number 5. So I can rewrite this as 1 plus or minus the actual number 5 all over negative 6. Now, in order to simplify any further, some problems it's hard to go much farther. If you have an I, you could stop at this stage because you would have 5i, but we don't. Since we have all real numbers, it's all reasonable numbers, all whole numbers, we can continue forward to simplify this a little bit into 2 separate problems. One of them being 1 plus 5 over negative 6. The other one being the minus half of that, 1 minus 5 over 6, because that over negative 6. That plus minus sign means we have a plus problem and a minus problem in the same one. 1 plus 5 is 6 over negative 6, which is equal to negative 1. Nice clean x-intercept. 1 minus 5 is negative 4 here over negative 6. Negative over negative is a positive, so and 4 over 6 reduces to 2/3. So it is a positive 2/3 as a solution. So these are the two solutions. This comes out cleaner than a lot of problems do. So just be aware that sometimes it's going to get real messy and you might even need to stop essentially at this stage, except with i's, and just rewrite as a positive version of that and a negative version of that. When it does come out clean, you can go all the way to nice answers like we did here.